Hi and welcome back to this third part of how to create custom peripherals or create custom IP cores for peripherals on your development board. This third part, in here we are going to look at how to write the software for our IP core, which we have now created in both part 1 and part 2. So let's have a look at it. From the Xilinx Platform Studio here, where we left off, having the custom IP core inserted into our project and everything, what you want to do here is go export the design and then export and launch. I have done that already, so I have my SDK running here, and everything regarding setup of the project have been exported to the SDK. So what we go to do now is to go up, create new, and then application project, and in here give it a name. Custom IP core, and select next. And we want to have an empty application because I have a test application that I'm just going to copy into my C project, and therefore we go finish here. So and we'll just go wait for it to get done compiling. So that's done. Then we need to have our custom IP project up here. We want to have a new C source file, and we just call that example.c and finish. So now here we have a empty C file into which we can start working. And as said, I have some temporary code or some example code that I've just done beforehand, which I'm going to copy in here and replacing everything here. And just to have a look at what's in here. So on my development board, I have 7 LEDs and I have 4 dip switches. And then I also have now my custom IP, which is interfaced to my 2 push buttons. So what I'm doing here is that I'm first, setting up these defines. So I have defined here on the base address of these 3 elements. These addresses you can find over here on MicroBlaze include, and then this xparameters.h file. Here you have the defines for your peripheral custom IP. You have your defines for your dip switches and for your LEDs. So these defines for the addresses come from this xparameters file. Inside this example C file, we're now using these to define our own defined values here. So what we do first is we take and set up whether they should be the inputs or outputs, and that's done in these 3 lines. And then we're doing something funny with data down here. So, well, funny and funny, but we are taking the values of our dip switches and of our push buttons and saving that into 2 temp values. What you notice is here that I've bit shifted this 4 bits in order for it to appear on the second hex value here, so that it looks nice on the LEDs. So what it will look like is that the first 4 LEDs are controlled by the dip switches, and the following 2 LEDs are controlled by our push buttons. So we don't need this. So this is the code. So try save the code, and it should compile. It says it has one error, so it's here. Oh yeah, of course. This code is not updated, so it should be called but in here, And we also should go for our X parameters file here and update. So this naturally is our base address. So we need to update it here as well, of course. So my mistake of copying old code, that's always what happens. So putting this in here. And then of course this one also needs to be updated. And save. So now our code is good to go. And we can take our Xilinx tools up here and start programming the FPGA. So what we do here is we take the system bit file and put into our FPGA. Yes, so now the MicroBlaze and all the logic is programmed into the FPGA. So now we're ready to run our software program on the MicroBlaze like this. And now I'm able to control my LEDs by the dip switches and the push buttons. So this were the end of this video session on how to create your custom IP core for your custom peripheral, how to implement it into the XPS Studio, how to customize the functionality of your IP core, synthesize it and get it over into the SDK. And here you saw how you should find the right parameters in the X parameter file, which I failed to do in the first attempt, but copying the right base addresses in here and correcting the names, everything ended up working. So I hope now you are able to go through the entire of this step guide on how to create your custom peripheral. Thank you very much for listening, and goodbye.